All right, this is the first day of Unit 6, and we're going to be doing a unit on rational expressions, rational equations, rational functions, super exciting stuff. So a rational expression is just an expression that's a ratio of two polynomials, so we'll see lots of polynomials still. It's just that now they'll be in cute little fractions like this. It's called a rational expression because it's a ratio of two polynomials. So quick review on how to simplify fractions. If you have something like this, a times c divided by b times c, it is totally fine to reduce that c and get an answer of a plus b. But that does not work if it's addition. If it's a plus c divided by b plus c, you can't reduce it. This is not good. Don't ever do it. You can't reduce terms if it's being added or subtracted. You can only reduce factors. So let's look at a couple of examples. The first one is 3x divided by 4x. It is fine to reduce those factors of x. So this reduces to 3 over 4. The next one is x plus 1 divided by x plus 2. We cannot reduce these x's because they're a part of addition. So you would just have to actually leave this one as is. It does not reduce or simplify. So it just is what it is. This last one, 2x plus 4 divided by x plus 2. Anytime you're looking at some kind of rational expression like this, you oftentimes want to think about factoring it. For the numerator, we can factor out a 2, so that leaves an x plus 2 in the numerator, and our denominator is x plus 2. Now at this point, you could notice that both the numerator and the denominator have an x plus 2. It is fine to reduce this factor. It's almost like this one's in parentheses too. You can reduce that. It has an x plus 2 in the numerator and x plus 2 in the denominator, and that does reduce. So this one reduces to the number 2. So let's look at a couple more. Number 1 is just multivariable. I like to think of it as each part. So I think about the numbers, and 8 over 2 gives me a 4. X to the third over x gives me an x squared. And we have a y divided by y squared. So we do have one factor of y, but it's in the denominator, not in the numerator. So this reduces to x squared divided by y. You want to think really hard about the location of the part that's left. That y does not belong in the numerator, it's in the denominator. All right, number 2. So x squared plus 5x plus 6 divided by x squared plus 3x. Now again, you cannot reduce those x squareds. They are terms, and you cannot do that. Is bad math. But if we factor both of these, we could possibly find something that might be able to reduce. X squared plus 5x plus 6 factors as x plus 2 times x plus 3. So essentially, again, what factoring does is factoring turns this sum, it's a bunch of things being added, into a product, which is things being multiplied. And so then we're able to reduce if we have a like term that can reduce. So the denominator here, x squared plus 3x, that is factorable, but it just has a common factor of x, and then it factors as x times x plus 3. So now that we have both the numerator and the denominator factored, now we can look for a reduction, and hopefully you notice that an x plus 3 can reduce. So that leaves our solution here, our simplification, as x plus 2 divided by x. Now again, those x's won't reduce because the numerator has an x plus 2. It has some addition happening. Okay, number 3, we have an x plus 4 in our numerator. Well, we can't do much with that. In our denominator, we have an x squared minus 16, and we can definitely factor that. If you remember, that's a difference of squares, so we have x plus 4 and x minus 4. So we can look for any factors that might reduce, and this factor of x plus 4 here does reduce. So what we have left is a factor of x minus 4, but it's very, very important to think about where that x minus 4 is. And it is in the bottom. It stays in the bottom. We would just put a 1 in the numerator like that. Number 4 is very, very, very similar, only a bit different. Instead of an x squared minus 16, we have a 16 minus x squared. If we wrote this maybe in a more standard form, it would be a negative x squared plus 16. And most of the time when we factor, we don't want to have a negative with our x squared, so we actually take care of that by factoring out a negative. So if I factor a negative from this first term, it just leaves an x squared. If I factor out a negative 1 from a positive 16, it leaves a negative 16. So this is the same as x plus 4 over negative x squared minus 16. Well, we can factor that x squared minus 16. So we have an x plus 4 over, and if we factor that, it's an x plus 4 times an x minus 4. And we still have this negative hanging out in front here. And now we look for things that might reduce, and hopefully you notice that this x plus 4 would reduce. And so if we write our answer, I'll often just put that negative either just next to it, or you can kind of put it where you want. You can leave it in the denominator if you want. Sometimes people will write it like this. The location of the negative doesn't matter a whole lot. You could write it any of these ways, and that would be fine. But that's what it reduces to. And again, that x minus 4 was in the denominator. It's in the bottom. It's not in the numerator. So make sure that it stays in that location. So this last one we did, it had a negative pop up, or a negative 1 if you want to think of it that way. So sometimes it's useful to start recognizing when something reduces to negative 1. So you can see here that the 7 reduces and the x reduces, so this reduces to negative 1. The x plus 2's here reduce, but you still have this negative, so that reduces to negative 1. In this case, you might factor that denominator by factoring that negative 1 out. Then you would see that reduction, and this does, in fact, simplify to negative 1 as well. In this case, our numerator is x minus 5. If I put my denominator in a more standard form, it would be a negative x plus 5. And I could, let's see, I'll write my numerator again. I could factor out a negative 1 to get a positive x. And if I factor a negative out of this, it would be a minus 5. And now you can see that it reduces to negative 1. So it's useful to be able to notice when things might reduce to negative 1. I have a couple for you to try. Hopefully I brought it around to you if you're in class. And here's the solutions for that. Anyways, it's really, really good to notice when things reduce to negative 1 or positive 1. Okay, so now we're going to talk about if we have two rational expressions, like I have this one and this one, and what happens when we multiply those two things together. Well, if you think about fractions, if I have a over b times c over d like this, it really is the same as having an ac in the numerator and a bd in the denominator. So this first example, it's the same as having an x plus 5, an x minus 6 in the numerator, and an x minus 6 and a 3x in the denominator. So if I look for a reduction, this would reduce. So oftentimes we might not necessarily rewrite that, and we would just look at this expression and just reduce like that. But it can reduce across multiplication just fine. So our final answer would be x plus 5 over 3x. And again, these x's would not reduce. You have to reduce factors, not terms. All right, so another one. Let's see if we can factor all of these expressions and then look for factors that might reduce. Let's see, this numerator, this first numerator, looks like it has a common factor of 3x. If I factor that out, I'm left with 1 minus x. In my denominator, it looks like I've got two factors, and I'm thinking of factors of -5 that add up to 4, so x plus 5 and x minus 1. And over here in my numerator, I'm looking at for factors of -20 that add up to +1. So x plus 5, x minus 4, and my 3x doesn't really factor much more than that. So if I look for things that reduce, you can see that that 3x reduces, and the x plus 5 reduces. And then I have these three other factors. I have a 1 minus x, I have an x minus 4, and I have an x minus 1. Well, hopefully you notice maybe that these two are very, very similar. So I'm going to look at this one a little bit more in depth. Another way to write that would be a -x plus 1. That puts it into more standard form with the highest power to lowest power. And I don't really like having a negative in front of my x, so I'm going to factor out the -1 to get an x minus 1 here. So another way to write this would be with that -1 and the x minus 1. And when you factor out that -1, you can see that these two reduce. So it leaves you with the final answer of -x minus 4 like this. Another one. If we factor this, let's see, we're going to have a 2x and an x. We're thinking of factors of 3 for these two spots. We need it to add up to 7. So I'm thinking we need the 3 here and the 1 here. And that does give us a 1x and a 6x. And that will add up to 7 like we need. So there's my little quick check. Usually I just do those checks in my mind. I think most of you do too. All right, and let's factor the denominator. X squared plus 5x plus 6, x plus 3, and x plus 2. And now our numerator here looks a little tricky. I'm going to go to the denominator. It looks like it has a common factor of x. When I factor x out of this term, it leaves a 2x. If I factor an x out of this term, it's going to be a plus 1. We've got to have like a placeholder for that when we multiply it out. Okay, looking at this top here, another way to write it would be -x squared plus 3x plus 10, putting it into standard form. And if I factor a -1 out of that, it gives me positive x squared, -3x, and -10. And that's what I'm going to put here, except I'm also going to go one more step and factor this. So I'm thinking of factors of -10 that add up to -3. So that would be an x minus 5 and an x plus 2. So now that I have everything factored, I can look for factors that would reduce or cancel each other out. There's a 2x plus 1. Here's an x plus 2 and an x plus 3. So that leaves me with a -1 times an x minus 5. All right, let's try one more. Oh, we're switching to dividing, sorry. So I want to remind you about dividing fractions. Dividing fractions is very, very similar to multiplying fractions, but when you want to divide, remember that it's the same as multiplying by the reciprocal. The d is now in the numerator and the c is in the denominator. And so anytime you see division, just remember that you need to multiply by the reciprocal. So this would become x plus 2 over x minus 1. This is my first expression here. And now it's times by The 3x is in the numerator now, and the x plus 2 is in the denominator. But it is times now. I see sometimes people leave that division symbol there. When you divide, it's the same as multiplying by the reciprocal. So it is multiplication now. And then the rules would be the same as before. We could reduce this factor of x plus 2 to get a final answer of 3x over x minus 1. So let's try a couple of these. So I have a 7x over a 2x minus 10. I'm going to leave that for now. And I want to divide. So I need to do the reciprocal here. X squared minus 11x plus 30 over x squared minus 6x. And since I did the reciprocal, it's now a multiplication problem. So now I could factor everything. 7x divided by 2 times x minus 5. So I factored out the GCF of 2 there. And over here, if I factor that numerator, I have an x minus 5 and an x minus 6. Those add up to negative 11 and multiply to give me positive 30. And in the denominator here, it looks like I just have a common factor of x. And if I factor that out, it leaves an x minus 6. Now that I have everything factored, now I can look for things that might reduce. Looks like the x minus 6 is reduced. The factor of x minus 5 reduces. And the factor of x reduces. This leaves me with a solution of 7/2. Another one, yay! So we have some division happening. So anytime you have division of fractions, you're going to multiply by the reciprocal. So we're going to multiply by 2x squared minus x over 3x squared minus 12x. This first expression stays the same. It does not change. So now let's factor everything. We have a 9x squared over, we've got a GCF of 3 here. That leaves an x minus, ooh, that's a really common mistake that I just made. It's not x minus 2. If I factor a 3 out of this term, it's a 2x. If I factor a 3 out of this term, it's a minus 1. In the numerator here, we have a GCF of x. That leaves a 2x minus 1. Don't lose that second term. And in the denominator, it looks like they have a GCF of 3x. And if I factor that out, that leaves an x minus 4. So now that everything's factored, I'll look for factors that would reduce. The 2x minus 1 factor reduces. We could reduce this factor of x. And I'm going to rewrite what I have now. Sometimes that's useful if you're not sure if anything else reduces. In the numerator, the only thing left is a 9x squared. And in the denominator, I have a factor of 3 and another factor of 3 and a factor of x minus 4. That's the same as 9 times x minus 4. Now that these two 3's, I combine them into the 9, it's easier to see that that 9 reduces and we get our solution as x squared divided by x minus 4. That doesn't reduce anymore. That's as simple as it gets. All right, so we have a super bonus challenge problem, and it looks really hairy, but it's not too bad. This is another way of writing division by fraction. So I've got a fraction divided by a fraction. Well, if I have a fraction divided by a fraction, that's the same thing as multiplying by the reciprocal. So I'm going to leave that first fraction the same. But the second fraction, if I do the reciprocal, I can turn that into multiplication. So the x squared plus 9x is in the numerator now, and the x squared plus 7x minus 18 is in the denominator. Now I'll look to see what I can factor. And actually, before I factor anything, I'm going to take a little bit closer look at this. I'm going to write it in standard form as negative x squared plus 3x. I'm going to factor out a negative 1 to leave x squared minus 3x behind. And that's what I'm going to factor for my expression. So I have x minus 2 in my numerator. Can't do much with that. I'm going to factor this for my denominator, so I'll leave the negative 1. And it looks like what I can do to factor this a little bit more is factor out an x. And in the second part over here, it looks like I can factor out an x from that numerator. And the denominator factors, we're looking for factors of negative 18 that add to 7. So I'm thinking it's a 9 and a negative 2, x plus 9 and x minus 2. Now that everything's factored, I look for factors that reduce. X plus 9's reduce, this x reduces. So I have a negative 1 and I have an x minus 3. That x minus 3 is in the denominator, so I want to leave it there. And that's our solution. And I think that's it. So the rest of the time, if you're in class watching this, the rest of the time you can work on that pink assignment in your notes. If you're doing it at home and you want to do the homework assignment, you can print it out if you don't already have a copy of it. I'll post a blank one for you. And next time when we meet after Thanksgiving break, we will start right away into the next section, which would be day 2. Thank you.